So this is the second lesson on vectors, and today you're going to be looking at operations with vectors. So the resultant vector is the sum of two vectors, and we can add vectors together using different methods depending on the notation of our vectors. So if our vectors are drawn in the arrow notation, then we need to draw the arrows nose to tail, and the resultant vector will be from the start to the end of the vectors. If the vectors are written in component form, then we just add the vertical components and the horizontal components separately. When we're subtracting vectors, we can make use of the property that if you make a vector negative, you reverse the direction of the vector. So negative A would be in the opposite direction to vector A. If we have our vectors drawn in arrow notation, we just reverse the direction of the second vector, place the vectors nose to tail, and draw the resultant vector. If the vectors are written in component form, then we need to subtract the vertical and horizontal components separately. Scalar multiplication is when we multiply a vector by a number. This changes the magnitude, so the length of the vector, but not the direction. If a scalar is negative, the vector will point in the opposite direction along the same line. If we have the vectors written in arrow notation, we just extend the arrow to the required length and change the arrowhead direction if it's a negative scalar. In component form, we multiply both the horizontal and vector components by the scalar. So let's look at this example. So given these vectors, we need to find some scalars such that this equation is true. So if I write out my equation, and perform the scalar multiplication, then I end up with so. Now we know that this needs to be equal to c, so I can equate the two vectors. And this gives me two simultaneous equations from the vertical and component parts of the vector. So now I'm going to use my simultaneous equations. So I'm going to substitute equation 2 into equation 1. So I find that k is 2 and m is 3. Two vectors are equal if they have the same magnitude and direction. Parallel vectors are scalar multiples of each other. So if vectors a and b are parallel, then we can write b equals t times a, where t is some scalar. To prove two vectors are parallel, you need to show that one is the scalar multiple of the other, and remember to write a conclusion. So the first thing I'm going to do is I'm going to find a plus pc. I know that that vector is parallel to 10, 23. So what that means is this vector is equal to some scalar times 10, 23. If I equate the vertical and horizontal components, I end up with two simultaneous equations. So if I say times equation 1 by 23, and equation 2 by 10, and then I can take one away from the other, and find p. final example. So if we're trying to find a vector parallel to that, let's call our vector A, then we know that it's equal to some scalar t times by the vector. So if A is a unit vector, then the modulus of A is equal to 1. So I know the square root of the square of my components is equal to 1. So I need to write down my final vectors. And I'm done. I hope you found this video useful and let me know if you have any questions.